How does the deep-sea drilling vessel Chikyu drill into the seafloor? When the vessel arrives at the drilling site, it receives a satellite signal that helps the vessel move into the exact position required. The vessel has 6 propellers that rotate a full 360 degrees and keep the vessel in one position, preventing it from drifting due to the wind, waves, or sea current. First, the conductor pipe is installed. As the drill pipes are connected, the conductor pipe and guide are run down to the seafloor. After the conductor pipe penetrates the seafloor, the drill pipe is released and pulled back to the vessel. A large drill bit connected to the bottom of the drill pipe is run down to the seafloor. The drill bit is led down to the bottom of the hole through the conductor pipe. The drill bit rotates and drills the sediment and rock below the seabed. Seawater is sprayed from nozzles on the drill bit to raise the cuttings to the seafloor. After drilling several hundred meters, the drill bit is pulled back to the vessel. A casing pipe, about 50 centimeters in diameter, is set into the drilled hole to keep it from collapsing. The casing pipe is run down through the conductor pipe and is inserted into the hole using the drill pipe. Cement is pumped into the space between the hole and the casing pipe to fix the pipe in place. After cementing, the drill pipe is released and pulled back to the vessel. The Chikyu is equipped with the riser system in order to drill into the earth even deeper. As the riser pipes are added one after another, the blowout preventer is run down to the seafloor. The blowout preventer is connected to a wellhead which is located on top of the casing pipe. The vessel is now connected to the seafloor via the riser pipe. A drill bit, smaller than the one first used, is run down through the riser pipe and casing pipe. The drilling begins. Once the riser pipe has been connected, drilling mud is used instead of seawater. When the target depth is reached, the drill bit is pulled back to the vessel. To drill the hole even deeper, a narrower casing pipe is set in to protect the drilled hole. After the casing pipe has been installed, cement is pumped into the space between the hole and the casing pipe to fix the pipe in place. Again, an even smaller drill bit is run down through the riser pipe and casing pipe, and the drilling continues. Repeating this process, the Chikyu will drill through the ocean crust to collect fresh, live mantle. This is something that has never been done before. Rotary drilling is used for ocean drilling. Let's look at the features of this method. First, the drill pipes are connected one after another as they run down to the seafloor. The work of connecting the drill pipes and drilling the hole are powered by a motor on the derrick. The drill pipe has a drill bit attached to the bottom. With rotary drilling, the drill pipe is rotated and the drill bit at the end crushes sediment and rock to make the hole. After a while, cuttings accumulate at the bottom and drilling cannot go any further. Seawater or other liquid is then pumped from the vessel down through the drill pipe and is jetted out of the nozzles on the drill bit. This liquid current forces the cuttings up to the sea floor. That is rotary drilling. The deep-sea drilling vessel Chikyu can drill over 7 kilometers below the seafloor into the earth. To drill even further below the seafloor, a riser system is used. With the riser system, mud is used instead of seawater. There are several reasons for using mud. First, it has greater viscosity than seawater to force cuttings up from the bottom of a deeper hole. Also, with the increase in pressure at greater depths, the formation pressure becomes much greater than the pressure in the hole filled with seawater. The hole will collapse if a certain differential pressure between the outside and the inside of the hole is reached. Mud has a higher density than water, therefore the pressure inside the hole remains higher, and the hole will not cave in, allowing deeper drilling. The drilling mud is artificially conditioned with various kinds of products, and it is expensive. Discharging it on the seafloor is bad both environmentally and economically. The mud is therefore collected and reused. For this purpose, the riser pipe is connected all the way from the vessel to the seafloor. The drilling mud sprayed out of the drill bit returns to the vessel through the riser pipe together with the cuttings and is collected and recycled at the vessel. Riser drilling not only makes it possible to drill deep into the earth, it is a breakthrough drilling method that is both environmentally and economically sound. Riser drilling will make it possible to drill all the way down into the Earth's mantle, a depth never before reached in all of history.
Chikyu's primary mission is to take cores for scientific study. Cores are cylindrical, continuous rock samples taken from geological layers. A device called a hydraulic piston corer is used to take cores from softer geological layers. First, the hydraulic piston corer is run down to the coring point by the drill pipe. Then the core barrel is run down through the drill pipe by a wire from the vessel. Once the core barrel is in place, it is ready to take a core sample. The end of the core barrel is sharpened to a knife edge so it can pierce the geological layers. Seawater is pumped into the drill pipe from the vessel to apply high pressure to the core barrel. In just 1 second, a 10-meter-long core is sampled. The barrel containing the core sample is pulled back up to the vessel by the wire. Then, the hydraulic piston corer drills ahead down to the next coring point. This method is used until the piston core barrel can no longer penetrate the geological layers. Once harder geological strata are reached, the hydraulic piston corer is pulled up. For hard geological strata, the coring system is switched over to the rotary corer. The core barrel runs down through the drill pipe without a wire. Samples are taken while drilling. The core barrel fills up with rock. To pull the core back to the vessel, a weighted wire is run down from the vessel and latches on to the core barrel. Then the wire and core barrel are pulled back to the vessel. One of the drill pipe joints is unscrewed, and the core barrel is taken out. These two coring methods allow precious core samples to be brought aboard the Chikyu. The Chikyu contains 4 floors of scientific laboratories. Here is how the analysis of the cores proceeds. First, each core sample is cut into 1.5 meter segments. The core's contents are scanned non-destructively. Then cores are split for study and preservation. Core properties such as density, heat conduction, and sound velocity are studied. Small samples are also extracted from the cores. Microorganisms in the cores are studied. Fossils, rocks, and minerals from cores are examined microscopically. The chemical composition of cores is analyzed. Cores are used to study the history of the Earth's magnetic field. Finally, all the cores are placed in cold storage for further analysis on shore. What can we learn from studying core samples? Physical studies characterize cores' mechanical properties, such as hardness and friability. Studying physical properties of cores reveals how the layer deforms when certain forces are applied to it. For example, cores from earthquake nests, where quakes frequently arise, can reveal the earthquake mechanism. Microbiological studies investigate the microorganisms within cores. These creatures live deep beneath the sea floor, where there is enormous pressure and almost no oxygen. These conditions are rarely found on the Earth's surface today. But the environment in which these organisms live may resemble the primeval Earth. So these studies could be a clue to the mystery of life's origins on our planet. Geochemical studies investigate the abundance of elements and other chemical properties of cores. Studying chemical properties gives clues about how the Earth's climate has changed over time. How cold or hot, wet or dry it was in past times. By understanding past environmental changes, we will be better able to predict those that may occur in the future. Core samples are not just rocks. They contain precious information about Earth's past, present, and future.